Okay, Art22, here we are in the second part of our sound visualization mini unit. So today we're going to be looking at something called the FFT and how we can use it as another way to analyze our sound and do something interesting with it. We're going to talk about what the FFT actually is in a minute. It's kind of a complicated idea if you really dig into the stuff behind the scenes. But I think there's a way that we can think about it in a more intuitive way in how we actually want to use it. So let's get to that discussion in a minute. I want to first basically just set up all of the initial parts of setting up the Minim library in our sketch. You're welcome to copy this from the previous sketch. I'm just going to do it again for practice. It's always nice to get a couple repetitions when it's a new topic. So why don't we set up our Minim library and initialize all the things we're going to need, and then we'll take a couple minutes here to discuss this whole FFT thing. It's kind of a cool idea, but it needs a few minutes of discussion. So let's go ahead and get set up, and then we'll get into that. Okay. So here we are, Class 2B of Week 6. Remember that Class 1 was your midterm, so we only have these 2 lectures for the week. Now, a couple things. Just like before, we need to have a data folder with the track we're using today. Today we are using a wonderful song from James Blake that also has a really nice beat that we can kind of really see the connections between the sound and visuals. So make sure you have that downloaded from the repo and inside your sketch folder. Great. Okay, so let's do similar to what we did in the last one, where we need to import our Minim library. We should already have it downloaded, so all we have to do is go import Minim, and there we go. There's our normal stuff. And let's just quickly go through this since we did it last time. So there we go, initializing our library. We're going to use the audio player again because we are, again, working with a song. So we'll name it song again, just to keep things consistent. And this time, instead of beat detect, we're going to be using the FFT class, and let's just call it FFT. Now, what does FFT actually stand for? It's a fast Fourier transform. That sounds fancy. We'll talk about it later, but briefly, get us info on the parts of our sound. Let's call it that for now, and we'll discuss more later. Let me put parts in quote, because that is a word that we're going to need to explore. If sound is something more familiar to you, we're actually going to be looking at frequencies. So low frequencies, high frequencies, middle frequencies, things like that. Okay, now let us go ahead and put our setup in here. I'm going to do kind of like last time, a narrow window, 500 by 200. I'm also going to stick with color mode HSB. I'm just kind of feeling that vibe these days. And now let's do similar to the last sketch where we set up the library, set up the song, and then set up the FFT. So we'll say minim equals new minim. And we discussed this last time, so I'm going to go through this a bit more quickly. We need to set up our song. So we're going to say minim.load file, kind of like image loading. And this time it's going to be called blake.mp3. I'll also put credits to this song in the YouTube comments, or not comments, the description. Perfecto. And you know what, let's loop this one to song loop. And then final thing here, which is the new thing for this one, we're gonna get the info about the song using our FFT equals new FFT. Now we need to pass some arguments. Let's not worry too much about these right now because they'll be the same every time. You don't need to deal with this, at least for what we're going to do in this class. If you're curious to know more about what's happening under the hood, I encourage you to go to the reference page for Minim and read more about it. But just know that this will work for our purposes, and you don't need to ever really change that for what we're doing in our class. Okay, and then why don't we just put the draw loop there just to have it, because we'll need it later. Great. So all of this is the exact same as last class, with the exception of FFT instead of beat detect. FFT instead of beat detect. And now we're using just a different song than before. Okay, great. All right, now's the time to talk about FFT. So let me switch over here. Okay, so FFT is, let me give you kind of the technical description of it first, and then we'll think about what it actually means in a more practical way. So the fast Fourier transform is basically a way, at least for our purposes here in audio with sound, is to, this is going to sound crazy, but we're going to convert information about the song from the time domain into the frequency domain. Now, what on earth does that mean? It actually might make more sense than you think. So basically what we're going to do is, if you've ever been to, let's say, a concert and seen the mixing board that they're kind of controlling all the sound from, or maybe someone has a nice stereo in their house or car or whatever, and you see all those little bars that are like kind of going up and down alongside the music. That's sort of similar to what we're going to be doing today. And so what this is basically doing is the FFT is analyzing our sound at every single moment in time and telling us what is that sound kind of made of. And what I mean by that is, what kind of frequencies are we getting in that sound at that exact moment? So you can imagine something that has like a really like strong kick drum, low bass kind of thing, would have a lot of energy in the low sounds with this big drum. And whereas if you imagine someone like whistling really high or playing a violin, would have a lot of energy and a lot more of the sound would be up in the high pitches. So that's what we're doing. We're looking at the makeup of the sound. How much really low sounds are there? How much middle sounds are there? Maybe like my voice is kind of in the middle range. And then what is like the really high pitched stuff that we're hearing. So this is a way that we can get information about those different parts of the sound and then use them in our visualization here. So let's sketch out a little bit what this looks like. So I mentioned that kind of real life examples of seeing this is usually like what they call like an equalizer or a visualizer or something like that. So you might have seen something like this. So let's say that we have, let's say we have this box here, which will end up being our processing window. So why don't I just make that actually the case? Now, this is what you might have seen before, like I said, at the mixing board at a concert or whatever. You have all of these bars. And they're kind of bouncing up and down. Different ones are bouncing at different times. And what these are the frequencies in the sound. So over here on the left side we have low, so like our low bass kind of. So if you think about like on your, you might have seen like bass and treble is like something you can change on your speakers. So low is like the bass, so low bass, and then all the way over here on the right is the treble or the highs. And then, it's basically a spectrum from low sounds on the left all the way to high sounds on the right. So this is what you might have seen, kind of a real world example of when we're looking at the sort of makeup of a sound. And so what we're going to be doing is the FFT object in Minim, when we put that into our draw loop, that means that every single time our draw loop is going, so basically at every frame of our sound, at every moment of the sound, we're going to be basically taking a picture of the sound, if I can use that metaphor, and we can see basically what how much low end is there, how much high end is there, how much stuff's in the middle. And the cool thing about it is it's like, okay, well, how can I actually use that information? So very conveniently, each of these little bars here, this is a good way to visualize it, all these little bars will have a separate number. So maybe this bar is at 0.6. Maybe this bar is at maybe like 1.1, maybe 0.8, 0.7, 0.6 again, and so on. So basically, every single frequency along this spectrum from low sounds to high sounds has a number. So it kind of has like a ranking. Like if it's really strong, like if you get like a really big bass drum, all the low sounds would be really high for a second and then come back down. If someone, I don't know, blew a dog whistle, like maybe the really high frequencies would bounce up and then come back down again. So basically we can use this number as basically a metric of how much high or low or middle there is. And in our case, there are almost over 1,000 of these mini little frequency metrics. Now this might be a little bit confusing at first, but I think when we see how we can actually use it for our visualization, it should help to understand why we would even use a technique like this. So what we're going to do is we're going to, first of all, we're going to just print out some of these numbers from the FFT just to see that there are numbers here. And then we're going to basically take this visualizer where we have all of the bars that represent the different frequencies of our sound, different maybe pitches you could think of it. It's not quite right, but it's okay to think about it that way. And we're going to basically make that sort of bouncing bar equalizer. And then the last thing we'll do is use it in a slightly more, we'll map it to something else, in this case, color. So let's jump into just seeing how this FFT works. And all I'll say is just remember that basically what the FFT is giving us every time we run it at every single moment in time is a list, like an array of numbers where each number corresponds to one frequency. So the very first number in this array will be the amount of the lowest frequency. So how much of the lowest low note, basically. The last number in the array is how much of the highest frequency are we getting. And then it ranges from low all the way to high. So let's take a look at that. Okay, so we've already set up our FFT to be going. And again, like I said, don't really worry about this part too much. We can talk more about that if you would like. What we do need to do is set up, why don't we set up first of all just a background color. Let's see, I think, why don't we just go with black for the moment. And we're going to want to stroke later, so we'll get to that in a minute. So first things first, just like we did with the last example, we need to tell the Minim library to start using this FFT function. Just like before we had said, hey, be looking at our sound and try to detect the beats, we want to be telling Minim to do our FFT analysis. Forward is just a particular type of FFT. Again, it's not important. You can just basically know that this is a function that's going to look at our sound and pull out information about the different frequencies. And what do we want to be looking at? Well, we want to look at /listen to our song again. So that's just like before. So instead of beat detect, we're saying, hey, run the FFT. So use FFT to listen to our song and get info about the different frequencies, or kind of like pitches, high, low, middle, etc. Okay. Now, let's just see what happens when we print some of this stuff out. So I'm going to say print line FFT dot get band. I'll explain that in a second. 0. One more parenthesis. Okay. So what this is saying, so when I drew this out with all those rectangles that are bouncing up and down, those are the different bands. So one bar is one band, and we said that we have a whole long list of these going from left to right, low to high. So when I say get band 0, that means get the information, the number about the lowest frequency of our sound. So let's print that out and see what we get. And we'll also hear what song we're actually working with. Okay, so that didn't tell us a whole lot, just a bunch of numbers, right? You might have noticed though, right when we got after that little intro part where it's kind of just the piano synth, when the first drum comes in, all of a sudden the numbers, which had been relatively low, around 2, 0 and stuff, popped up to like 43, and then again 44, 81. So we were we're seeing that whenever that really low kind of drum type of sound came in, those low frequencies really jumped up to a higher number and then went back down again to a lower number. So that's kind of how this FFT thing works. We looked at that for the lowest frequency. Let's just look at it for a much higher frequency, like 1,000. So this is like a really high-pitched frequency. Oops. So already we noticed that the numbers are a little bit lower, smaller than the other one. And we noticed that even when the drums came in, that didn't really change much, right? Like it's still hovering around 0.0 something. So these much higher frequencies, all the way at the end of our list of frequencies, weren't really affected by that low drum sound or the low piano, because those sounds are more in the low range of the sound than the much higher sound. Again, if we had a really high-pitched violin or something like that, then these numbers for frequency band 1000 would have probably jumped up. But because we are hearing a lot of lower sounds, these weren't really affected. Okay, so why is that important? Well, now what it allows us to do is use this FFT, and now we can map specific parts of our sound to the visual. So with the beat detector, that's really nice because we can get the pulse of the song, but we can't really differentiate between like lower sounds and higher sounds, and that's what the FFT allows us to do. So let me just put both of these here as a reference. FFT.getBand 0. Oops. So I'm going to say print info on the lowest frequency, print info on a very high frequency. Well, it's called a very low sound, let's say. Sound. Very cool. So that's just a reference to have of what we're actually seeing. I'm going to comment them out though for now. Great. All right, so now what I want to do is use a loop. And I basically want to go through, I don't want to just deal with just one of these frequency bands, like not just the lowest one, not just the highest one. I want to use a loop to go through all of them and then draw them as lines, so that we can kind of emulate the idea of having the mixing board style bouncing bars showing us information about the music. And I'm hoping that once we see this, you'll kind of get a more intuitive understanding of what this FFT is actually showing us. So I'm going to say we're going to loop through all frequencies in the FFT and draw lines for each band. That's the term for each frequency. Okay. So first things first, I just need a standard loop. Int I equals 0. That should look very familiar. Now, our goal here is to loop through all of the frequencies of our FFT. Now, even if we didn't know the number of that, I just happen to know that if we go FFT.spec size, that's going to go from 0 to the length of our FFT array. So it's kind of like when we said we had an array and we said go from 0 to numbers.length. This is the same thing. It's saying go through the entire length or the size of our FFT array. Okay, and we'll just do I++ like normal. Okay, so now we have a loop that's going through all of the frequencies of our sound at every single moment in time. Very cool. Now I'm going to draw some lines, so I need a stroke weight for that. I'm going to say 10. So these would be kind of a little bit wider lines. Now what I want to do for the lines, let me type it out and then we'll kind of think about what this means. So I want to draw the X coordinate of our lines. I'm going to skip the Y for a second. So I want the X, so if you remember, line takes an initial X and Y starting point and then an X and a Y end point. So what does it mean if I say I want my lines to be at I for the X coordinate? Well, we know that I is going from 0 up to around 1,000, let's say. So that means that our first line will be drawn all the way over here on the left at 0. Then the next line will be drawn at 1. Next line is drawn at 2, then 3, then 4, then 5, and 6. So basically, the lowest frequencies will be drawn over here on the left, and the highest frequencies will be drawn over here on the right. Okay. Now what about the Y component? Well, I want my lines to start at the bottom. So I'm going to say that the initial starting point of the line is at height, so all the way at the bottom. So 0 is at the top, height is at the bottom. So I'm going to say that the starting point of my line is I height. So that basically means the first line will start at 0 I, which is all the way on the left, and then all the way down here at height, bottom left corner. All right, now this is where we actually use the FFT information to draw our lines. So now I'm going to say the Y coordinate of the end point of our line, so how high up do I want this line to go? We're going to use this kind of clever trick here to say height minus FFT.get band I. Okay, what on earth does this mean? So when we printed out, let's say, for example, this first frequency, right? We were getting numbers that started around 0 and then sometimes jumped up to like 80. So what is height minus 0? Well, that's basically still at the bottom, right? What is height minus 80 though? Well, that's probably height minus 80 pixels. So like maybe right around here. So that basically means the bigger the number for our band, get band I, so whichever frequency we're on, the bigger this number is, the taller our line will be, because we're subtracting more from height. Okay, let's see what this looks like. I'm going to give this also a stroke color I'm realizing we need. I want to do this stroke 0, but I want the background white. Okay, let's just see what we got. Okay. So we're seeing a lot of low end right now. Aha, okay. So we can hear that hi-hat is really in this kind of middle frequency range, middle to highish. Because this is kind of going with the hi-hat. You can see here is maybe kind of where a lot of the snare drum is living. Okay, very cool. So one thing I want to do is I want to make it a bit more dramatic how much these lines are changing. So I'm just going to add a times 4 to this number just to kind of scale it up a little bit. So basically across all of the frequencies, I'm just going to multiply everything by 4 just to make it a bit more noticeable, a little bit bigger. Let's just see what that gives us. Okay, yeah, you can see that we are spreading out further now, which is a little bit nicer. Let's wait for this hi-hat to come in and then that snare later. Now we can really see that snare popping up and then this hi-hat over here. Awesome. So this should look a little bit like what you might see on a mixing board or on a kind of fancier stereo or whatever. But it might still be a little confusing, which is understandable. This is not a very easy concept, especially if you're not haven't worked a lot in sound before. So just to illustrate this point a little bit more, let's take the loop part of this out of the equation. Let's just look at one individual frequency and draw a line for it. So I'm going to, for the moment, comment this out. And I'm going to say, let's do the same thing. I want a stroke weight of 10. I want a stroke of black, 0. Now let's just draw one line. So I'm going to say line. And what I want to do is I want to say, instead of, so this loop went through all the frequencies, let's just grab one that's kind of on the lower middle side of things. So earlier we looked at the numbers for the lowest frequency, 0, like the ones on the left, and we looked at 1,000, the ones way over here on the right. Let's look at the frequency that's at 150. So I'm going to say, let's put our X at 150, let's say. We're going to do the same method as we did here for our line. We're going to draw them from the bottom, going up. 150. But now this time, instead of FFT.getBand I, which would be all of our frequencies, let's just do one very specific one. Get band for the 150th frequency. We'll use our times 4 again. So this right here is the exact same thing as what we just did with our loop, but instead of doing it for all frequencies, we're just doing it for this one frequency at 150. Let's do this. Let's also print out the number just so we can see what we're actually looking at. Print line FFT dot get band 150 times 4. So we're going to draw a line based on this one frequency, but then we're going to also print it out to see what that number is. Okay, so we can see we're kind of 0, 1-ish, so it's hovering down here. Now when the sound changes, let's see if we can kind of see what's happening. Aha, okay. So this one's very much in that snare drum range. So you can see it flying up when the snare hits. And we can see that in the numbers too. If we just scroll back here. Yeah, so we would kind of be going at around 0 or 1, and then we got a 23, probably a snare hit there. Yep, some 10s. Some 10s again, yep. Some 41, so kind of a really strong, maybe snare hit. Okay, so that's what's happening for just one frequency. The frequency that's 150th in our list of frequencies. So what hopefully that shows is that, let's say I wanted to make a visualization that's really focusing on one part of the sound. So not just the beat, but maybe I want this to really focus in on the snare, which I kind of found to be around 150 for the frequency. Maybe you want to really explore some of the higher pitch stuff, so maybe you'd use the FFT get band at a much higher number, like 1,000 or something like that. Okay, so let's do one last thing with this, and then I'm going to show you an example assignment, and I'll also post the code as well. So what I'm going to do is comment this out. But now that I've sort of found out that the FFT at around 150 is a really nice kind of indicator of when our snare drum is happening, I want to use that as part of my visualization. So here's what we're going to do. I basically want to have an ellipse where the color is changing based on the numbers we're getting from this FFT. So let's do one quick thing before we jump into that. I'm going to get rid of our multiply by 4 thing here. Let's just see what the actual raw number is for how much of this frequency we're getting in our FFT. Okay, so it's still around zeros. Let's wait for that snare to come in just to see what this jumps up to. Okay, so I think I saw, yeah, we jumped up to 13 when the snare drum hit. So we were zeros, 13, zeros, and then we didn't get another one yet, but that's okay. So we can basically say that FFT band 150 is a good indicator of the snare drum, and the values range roughly, let's say, between 0 and, how about 15? Because we saw 13 in there, maybe we'll have a stronger one that's closer to 15. All right, so we know that basically this is going to give us, FFT get band 150 is going to give us a number roughly between 0 and 15. So what we want to do is use that map function, which you've seen before, to take this range of numbers from 0 to 15 and convert it into a range that works for our colors. So I'm going to make a color variable up here at the top. I'm going to say color C. Actually, you know what? We don't even need to do a color because we're doing hue, saturation, brightness. Let's just do a float. Okay. So we're just going to have a floating point number. That's C. And so what I want to do is I want to use C to map our frequency information between 0 and 15 to be between 0 and 255, or actually 360 because we're using hue, that color mode. So our map function, if you recall, what do we want to map? Well, we want to map FFT get band 150. And what was the old range of FFT band 150? Well, we know it was between 0 and about 15. And we want to use this as the hue color, so we want to change it to be between 0 and 360. So we'll say map FFT get band 150 from, let's say, sound range to color range. That's what's happening here. Okay. Now let's actually use that. So let's set our fill color to be that value that we just mapped. And then let's just set the hue, I don't know. I'm sorry, the saturation, the brightness to like 200, 200. That's just kind of a off the top of my head guess. Now why don't we actually draw something, right? So we'll say ellipse height divided by 2. Nope, wait, divided by 2. Height divided by 2. We need a size. We'll go, how about a 50 by 50 ellipse? You know what? I'm going to get rid of that stroke. No stroke. Very cool. All right, so before we run this, let's think about what we're doing. Not print this out for a second. We're getting the information about that kind of snare drumish range of the sound, and we're converting it into a number that fits between our color, 0 to 360 for hue. Remember the color wheel. Then we're setting the fill color based on that number, and then we're drawing an ellipse with that. So let's check it out. Okay, cool. So now what we're seeing is, you know, the small variations in numbers when nothing is happening give it this little flickering effect. And then when there's a much stronger like snare drum hit or a sound that's in that range, we're getting this color shifting. And what I like about this example is that, you know, when you see this, if you didn't know anything else behind the scenes, you might not know exactly why this is changing the way it is, but I think you do get a sense that it's somehow tied to the music, which I think is the beauty of this whole sound visualization thing. Is it's a little bit mysterious, but you can also create these cool effects that sync up the visuals and the sound. And I think with something like this, you can imagine really exploring a lot of different ideas, color, shape, movement. You can have how things are moving is based on these numbers from the frequency. There's a lot of options. Speaking of, I'm going to leave you today with an example for the assignment that I made. Let me pull that up for you. Okay. Jumped over here on the other screen. Let me save this. Let's get rid of that for a second. Okay. So I'm not going to go super in detail into what I'm doing. I'll leave that to you to pick through the code because I'll post it. But basically what I'm doing is I'm using both of the beat detector and the FFT for my visualization. So I'm using that original track, Denmark, that we saw in the first example. I'm detecting the beat, I'm detecting the FFT. Now what I'm basically doing is saying, whenever the beat comes in, I basically draw this rectangle and rotate it according to the beat. So here's the crucial part. Every time there's a beat, I draw a rectangle and I rotate it by a certain amount, and then I increase that rotation every time there's a new beat. So again, I'm not going to go super into detail with this. I just wanted to show you an example of something I made with this. And let me run it first and then we'll talk a bit more about it. so basically what you can see is happening is every time a beat occurs, it rotates this rectangle by a certain amount. I think I say by 5 degrees maybe. Yeah, rotate radians R. R is increasing by 5 each time. So basically what I do is I increase it by 5. And then what is this little weirdness here? If R modulo 90 equals 0, W plus equals 100. What the heck does that mean? Well, that means after I've rotated 90 degrees, then, so R has gone from 0 all the way up to 90. Then I add to W. What is W? W is the radius of my rectangle, or the width and height of my rectangle. So basically, after I've rotated full 90 degrees, then I make the rectangle bigger by 100. So that's just so that I can keep drawing it out further and further and further. And then basically what I do, the other little bit of fancy stuff here is that I'm keeping track of when the last beat happened in this variable. And then I basically am saying, if it's been longer than 1500 milliseconds since the last beat we heard, go back to this sort of random screen like we're actually about to see right now. Go back to this kind of flickery random screen and reset our width and our rectangle rotation. So we just did that. Now we're back to kind of the beat detector rotating our rectangle. And you can see that because it's been a while between some certain beats, things get reset. There it is again. Okay. Now the other thing that's happening in this sketch is kind of what we saw in the example from today, which is I'm looking at the frequency band 10 of FFT and using that for my hue. So all the colors you see for this rectangle as they're changing are based off of that frequency band 10 from our FFT. So basically there's two components. I have color based on FFT, and I have rotation and growth of the rectangle based on when the beat is happening. Okay, so I will upload this code for you to kind of pick apart and digest. If you have any specific questions about it, always let me know. Happy to discuss it more, but I just wanted to provide an example of how you might use these two tools to create your own sound visualizer for this week's assignment. Okay, good luck with that. Pick some music you like so that it's more fun, and I'm excited to see what you all cook up, and have a great week.